All right, today we're going to talk about solving systems by substitution. And so remember, systems are just two lines and we're looking for where they intersect. And so when we solve it by graphing, we need both of them in slope-intercept form. And so our first equation is in slope-intercept form. I can see that the slope is -2. The y-intercept is -8. So we're starting at -8. On the y-axis, and then since our slope is -2, remember that's technically over 1, so we're going to go down 2 for our rise and right 1 for our run. So down 2, right 1 to get our negative slope. To continue the pattern, we could go up 2 and back 1. That would continue giving us a negative slope. And then remember, put every point, because you never know which one could be your intersection or your solution. Okay, this second line, we need to rearrange it. So first move is to put the x on the other side. And so when we put it on the other side, it becomes a -2x. And we still have the +12. And then we need to divide every number by -4. And so when we simplify our fractions, -2 over -4 will be +1/2. That's going to be our slope. And then +12 over -4 will give us a -3. That will be our y-intercept. And so m is 1/2 and b is -3. So starting at -3 on the y-axis, we're going to rise up 1 and then run right 2. Up 1, right 2, and if we go down 1, back 2, that's going to land us at our intersection. Okay, and so we can see that our solution is -2, -4. -2, -4. It's an ordered pair, parentheses, and a comma. Need both of those things. Okay, so to check the validity of the solution, you would just plug this solution into both equations. We're going to plug the -2 in for x, the -4 in for y. And so for my first equation, it's y equals -2x minus 8. And so if y is -4, and substituting x being -2, we should get a true equation. Okay, and so number crunching, -2 times -2 is +4. If we subtract 8, we get -4. So our solution satisfies the first equation. For my second equation, we have 2x minus 4y equals 12. And so once again, x is -2, y is -4. We should get a true equation. This would give me -4. And -4 times -4 is +16. -4 plus 16 is 12. And so it does work. Okay, and so that's how you solve a system by graphing. We have other methods that don't involve graphing that a lot of people like. Our first method is substitution. We'll learn a different method called elimination in the next lesson. So for substitution, your first step is to solve one of the equations for one of the variables. Okay, and so here it's already solved for y. Our top equation is, and so that step is done for us. And so I'm going to go ahead and write down that equation. Step 1 has one of the variables already solved for, y equals. Okay, that just means isolate. So solve means isolate. And you could isolate x or y. Okay, and then we're going to use that new equation from step 1 to plug in to the other equation. So the other equation is 2x minus 4y equals 12. And we are substituting y. Okay, we know what y equals. It's equal to negative 2x minus 8. And so recopy this equation without the y and leave some room, put a blank set of parentheses, and we are going to replace it with negative 2x minus 8. That's his sub, okay? And so we're going to put the negative 2x minus 8 into those parentheses. Okay, and so the reason we want to do that is because now I've got an equation that only has x's. And so I can solve this one variable equation for x. Our first step is to get rid of the parentheses by distributing the negative 4. And so negative 4 times negative 2 is positive 8x. Negative 4 times negative 8 is positive 32. And then I have some like terms. 2x plus 8x is 10x. And then to isolate x, we have to get rid of this 32 first. Get rid of what's not attached to your variable, and then divide by 10. So that gives me x equals negative 2. Okay, that's only the x value. Remember, our solution is an ordered pair, x and y. Right now, we only have x, okay? And so step 2 is done, well, and step 3. It says, oh, no, not step 3. So we plugged into the equation, and then we're gonna solve for the remaining variables. So we just did that. I'll just point to it. That's where we solved, okay? And so we have x equals negative 2. And so we're going to use the solution, x equals negative 2, to solve for the other variable. Okay, so we have our equation here, y equals negative 2x minus 8, and we know x is negative 2 now. Okay, and so if I simplify this, I get 4 minus 8, which is negative 4. And so now I have my y variable. And so my solution is negative 2, negative 4. And this was the same system we solved in the warm-up by graphing. And so we could, of course, plug this back in and check. Okay, and so write your solution as a set of coordinates like we just did. Right, and so in general, I like to organize this in a column method. And so to do this next example, I'm going to show you the column method. First of all, solve one of your equations for a variable. That's done for us, okay? And so whichever equation is already solved, put that equation on the left side, and then on the right side, put your other equation. Okay, and so identify which player is getting subbed out of the game. Y is getting subbed out of the game. It says y equals, and here he is in the game. And so after you realize he's the one getting subbed out, go ahead and take him out of the game. Leave him a blank set of parentheses. And then now we're going to put his sub, 3x plus 1, into the game. Kind of like in a sport, basketball or volleyball, you sub out a player. That's what we're doing. We're subbing out y, and his sub is 3x plus 1. Now I have a one variable equation. So I'm going to solve it by first distributing. Combine my like terms, which is 9x and 6x. Subtract the 2 to isolate my x term. And then divide, and we get x equals 1. Okay, and so once you have that x value, I like the column because it kind of reminds you to go back and get your y variable. And so now I know that x is 1. That tells me y would be 3 plus 1, which is 4. So now I have my x, I have my y, and I can write my solution as an ordered pair. X is 1, y is 4, and so the actual solution as an ordered pair, use your parentheses, use your comma. Okay, on number 2, neither equation is solved for. And so in that case, pick an equation where it would be easy to solve for a variable. It would be easiest to solve for this y because he doesn't have a number in front of it. And so he's going to be the easiest to isolate. And so I'm going to make my columns, and I'm going to choose the second equation to solve it for y. Okay, and so all we have to do is move the x to the other side, or you can think of it as subtracting 4x from both sides. Just make sure you don't combine it with that 24 that's already there. Those aren't like terms. Okay, and so now y is already solved for. My other equation that I haven't used yet is going on this left side. Okay, y is the player getting subbed out of the game. And so we're going to take him out of the game. And his sub is negative 4x plus 24. Negative 4x plus 24. Okay, now we're ready to solve our equation. Distribute first. We're distributing a negative 3, which would give me positive 12x minus, and then negative 3 times 24 would be 70 minus 72. Bring down that 2x. And then our like terms, 2x plus 12x is 14x. Still have our equals negative 2 over here. And then we can add 72 to both sides. And so we get 14x equals 70. Okay, and then we divide by 14. I'm not sure what 70 divided by 14 is. Okay, and so we get x equals 5. And then now we can go back to our original equation and fill in 5 for the x. Okay, and so that gives us negative 20 plus 24, which is 4 for our y value. We got x, we got y. We have our solution. Okay, on number 3, this one would, both of them are already solved for y, and so that makes it pretty easy. You can pick either one to go on the left side, so y equals 2 minus x, and then you can pick either one to go on the right side. Okay, so just be careful which player is getting subbed out. Y is the player getting subbed out, and he's over here on the left. Okay, and so when I sub him out, we are putting the 2 minus x inside. And since there's nothing to distribute, these parentheses are kind of unnecessary. So it's just 2 minus x equals 3x minus 6. And then we can isolate, well, first we need to get rid of all of these x's. Either side, I'm picking the one with the negative x. And then we can add 6 to both sides. And then divide by 4. And we get x equals 4. Okay, and so we're going to take that x equals 4, and we can substitute that x into either equation. They're both pretty easy. So 2 minus 4 would give me negative 2 for my y value. Okay, and so my solution is 4, negative 2. Okay, on number 4, we got a fraction to deal with, but at least y is already solved for in the second equation. So that's the equation I'm going to put on the left. And this problem looks very similar to ones I've seen on Star, and so that's why we're doing it. Okay, so y is the player getting subbed out of the game. And so leave that minus sign and put your blank set of parentheses. Take y out of the game. And his sub is 3x minus 5 over 10. That's where we're going to put it. 3x minus 5 over 10. Okay, and so we have to distribute this negative, but when we distribute it, we don't want to distribute it to the top and bottom. We only distribute it to the top. Okay, and so it's going to be minus 3x plus 5. Over 10. Okay, and then now whenever you see a fraction anywhere in the equation, what you can do is scale the entire equation. The entire equation. It's only legal if you do it to the whole equation by 10, by whatever that denominator is. Okay, and so that 10 gets distributed to all three places. And so when I do that, my first term, 10 times x is 10x. 10 times this fraction, the 10s are going to end up canceling, leaving me with just that negative 3x plus 5. And then 10 times the negative 10 would be negative 100. Okay, so that's just a trick to get rid of a fraction. You can scale an entire equation as long as you do it to every single term. Okay, from here I have 7x plus 5 equals negative 100. I can subtract 5 from both sides. And I get negative 105. And then when we divide by 7, we get negative 15. Okay, and then we can take x equals negative 15 back to the other side and substitute it for the x, and then simplify. 3 times negative 15 is negative 45 minus 5. Gives me a negative 50 on top. Negative 50 over 10 is just negative 5. Okay, and so we have x equals negative 15, y equals negative 5. That would be our final solution. Okay, on number 5, once again, none of the variables are already isolated. And so we can pick any equation. I think either x or y would be easiest to solve for. And so I'm going to solve the top equation for y. Okay, and so my other equation is going to go over here on the right. Okay, and so to solve it for y, we need to put the x on the other side. So y equals negative x plus 3. And so now y is solved for. Okay, and so y is the player getting subbed out of the game. Make sure you sub out the correct player. And his sub is negative x plus 3. That's where the negative x plus 3 is going to go. Okay, and so when I distribute, I get positive 4x minus 12 equals 12. Okay, and then here, negative 4x plus x cancels, leaving me with just negative 12 equals 12. And so if you remember from Unit 1, anytime your variable cancels and leaves you with a false statement, negative 12 does not equal 12, your answer is no solution. Okay, no solution. Okay, and so this would be an example of parallel lines. If we were to put them both in slope-intercept form, we would see they have the same slope but different y-intercepts. Okay, on this next one, y is already solved for, and so that is the equation I'm going to put on the left side. And then on the right side, I'm putting the other equation, and we are subbing out the y. why is the player getting subbed out of the game? His sub is 3x plus 1. Okay, and so when I distribute the negative 3, I get negative 9x minus 3 equals negative 3. 9x minus 9x is 0x, so no x's. My variable dropped out, and I'm left with a true statement. Negative 3 does equal negative 3. And so instead of saying all real numbers, remember our solutions are ordered pairs. So this is a situation where we say infinitely many solutions. Where the abbreviation is IMS. Okay, IMS. Just do not say all real numbers for this situation. Okay, and so this would be an example. If I were to solve both of them for slope-intercept form, they're the same line. Okay, we would see them graphed right on top of each other.